In today's lesson, we are going to look at the ambiguous case. The ambiguous case applies when you are dealing with the sign law, and this is a situation in which two triangles could be drawn, given the available information. The ambiguous case may occur when the given measurements are the lengths of two sides and the measure of an angle that is not contained by the two sides. What that means is this. You're given two side measurements and one of the angles that is not in between. This angle here would be considered included. We are not given that piece of information. We are given one of these other angles. So we have what's called the side-side angle property. In this case, it might be possible to draw more than one triangle. So for example, if we look at the first one, if angle A is acute, so it's a less than 90-degree angle, and side A, so the side opposite this angle, is less than H. H is the side that would occur if you had a right triangle. So in this case, side A measures less than what the side would be if you had a right triangle. How many triangles are possible? Let's have a look. So that would be right here. If we took this side and we look, it's definitely less than the side that gives us our right angle or our right triangle. If we swing it like a pendulum, at no point is it going to come down and touch the line on the bottom to form a triangle. So in this case, there are no triangles possible. What happens if angle A is acute and the side opposite it equals H? H was the side that formed a right triangle. So if they are equal to each other, you would have one right triangle. What happens if angle A is acute and side A is greater than side B? So side B was the side adjacent to angle A. A is larger than B. You are only going to have one possible triangle. What happens if angle A is acute and side A equals side B? Again, you are only going to have one triangle. What happens if angle A is acute and the length of H, so the length of the side that forms a right triangle? So if A is greater than H, but it is less than side B, we want to look to see what happens. So what we have is we've got A is greater than H, but it is less than side B. Let's see what we get. Well, we have a triangle that happens right there, and when we swing it around, we have another triangle. So with that information given, when the side opposite the given angle is longer than the side that would form a right triangle, but shorter than the side adjacent to the angle, we have two potential triangles. And this is our ambiguous case. So there are two possible triangles. If we have an obtuse angle and A is less than B, there will be no triangles that are formed. And if A is obtuse and A equals B, again, we will have no triangle. If A is obtuse, A must be larger than B for there to be a triangle. This chart summarizes what we just looked at. So there's two different bubbles. One is for if angle A is acute, and one is for if angle A is obtuse. So if angle A is acute, and the side opposite the angle is less than the H, which would form the right triangle, there is no triangle. If A equals H, there is one triangle, or if A is greater than B, there is one triangle. Where we have our ambiguous case is if A is larger than H, but smaller than B. There are two possibilities. If the angle A is obtuse, so if it's larger than 190 degrees, if A is less than B or equal to B, there is no triangle. But if A is larger than B, there will be one triangle. So what we want to do here is each of these situations is a side-side angle situation. We want to determine how many triangles would be possible. So what we do is we set up, we've got angle A is 30 degrees. So angle A is 30, side A is opposite angle A, that's 4, side B is 12. Now what we don't know for sure is if it actually forms a triangle. So that is our question mark. So what we want to do first, before we can continue here, is we need to find what that value of h would be. What is the length of the side that will give us a right triangle? And remember back to trigonometry for right triangles. You can use your sine, cos, and tan laws. We know the length of the hypotenuse in this case. It's 12. We know we're looking for the opposite side. So the trig law that uses opposite and hypotenuse is sine. So if we find the sine of 30, it equals h over 12. The sine of 30 is 0.5 multiplied by 12, and you would get 6. So what we have is 6 is the length of h. So now what we need to do is we need to compare side 4 with side 6. So this is our A and our H. And as we can see, A is less than H. And if we go back to our table, when A is less than H, there is no triangle. So for this one here, there would be no triangle possible with that given information. Let's look at B. We're dealing with a 30-degree angle again. The side opposite the angle A is 6. The other side we are given is 12. So we need to determine. Now in this case, we are still using 12 and 30, which is what we used in question A. So it's the same sign process we had here. So we know that H equals 6. So when we are comparing A to H, we are comparing 6 to 6, and we are finding that they are equal. When A equaled H, we had one right triangle. So this one would actually have formed one right triangle. If we look at C, again we are dealing with A being 30 degrees. Its opposite side is 8, and we still have the adjacent side of being 12. So therefore, we can still use the same sign, and we know that 6 equals H. So now if we're comparing A to H, we have A is 8, H is 6. A is larger than H. So if we go back here to our table, when A is larger than H, we also have to check how it compares to B. A is less than 12, so A is less than B. So if we go back here, when A is less than B, we have two possible triangles. So here is our ambiguous case. There are two possible triangles that could occur. It could be something that looks like this, or it could be something that looks like this. In D, 30-degree angle, opposite side is 15, B is 12. A is greater than B in this case. Oops, so we've got A is 15, B was 12. A is greater than B, and when A is greater than B, we have one triangle. So it's important to know that you need to check for that information when you are given a set of opposites and one other side. So here's our last question. Martina and Carl are part of a team that is studying weather patterns. The team is about to launch a weather balloon to collect data. Martina's rope is 7.8 meters long and makes an angle of 36 degrees with the ground. Carl's rope is 5.9 meters long. Assuming that Martina and Carl form a triangle in a vertical plane with the weather balloon, what is the distance between Martina and Carl to the nearest tenth of a meter? So we've got our weather balloon, and we've got Martina and Carl are holding ropes. Martina's rope is 7.8 meters long and makes an angle of 36 degrees. Carl's rope is 5.9 meters long. We are assuming they form a vertical plane so we can draw this type of triangle. So here's what the problem is. When you set this up, you now need to look. Do I have an ambiguous case? This type of a problem right here would be a level 4 problem. All ambiguous triangles are either a 3 or a 4 in the rubric. What you would have to then note is now I need to check how many possible triangles I have. So I'm going to have to start by finding what my H is. So my right triangle is on the right-hand side because that is where I have the angle I know. So I'm going to go sine of 36 equals H over 7.8. And I am going to do that calculation, and I'm going to find the sine of 36 is 0.587785 equals H over 7.8. And I'm going to multiply by 7.8. And I'm going to find that approximately 4.6 is my H. So now I need to compare. The side that was opposite the angle I was given is 5.9. How does that compare to H? That's what I'm going to call my A. Always the side opposite the angle you're given. A is larger than H because 5.9 is larger than 4.6. Now then, I need to compare A to the other side I'm given, B. And in this case, A is less than B. And when this occurs, when A is larger than H but less than B, we have two possible triangles. Because there is no more information in the question given to us, we have to solve both possibilities. So what we actually have is we have a potential triangle that looks like this, where we've got 5.9, 7.8 with the 36. But we also have a potential triangle that looks like this, 7.8, 5.9. In both cases, we want to find the distance that the two people are standing apart. So we now have two questions to solve. We can use our law of sines to solve these because we're given an opposite piece of information. And so what we can do now is we can find what we can find here is not going to get us our side x at this point in time because we have a set of opposites, but these two sides are not opposite of each other. We need an angle and a side. So the first thing we're going to do is we're going to find this missing angle in here. That will then allow us to find the third angle, which will allow us to use the law of cosines. So this is a lengthy question. So what we now do is we've got 5.9 over sine 36 equals 7.8 over sine theta. We can do our cross multiplication and division, and we can do all of that in one step. We can multiply sine of 36 by 7.8 and then divide it by 5.9. And when we do that, we end up with decimal 77707 equals sine theta. Use your second function, sine, and you will end up with 50.99 equals theta. What we can now do with that information is we want to find this angle up here at the top. We know that three angles add up to 180. So what we can do is we can subtract 50.99 and 36, and we will get an answer of approximately, and I say approximately because we rounded at one angle, of 93.01 degrees. So this is the angle that is up here in this corner. Now we can use the law of cosines to find x. X is the side we are looking for. It is the side opposite the 93 degrees. So we have 5.9 squared plus 7.8 squared minus 2 times 5.9 times 7.8 times the cos of 93.01. We solve everything on the right-hand side. So we find 5.9 squared, we add it to 7.8 squared, we subtract 2 times 5.9 times 7.8 times cos 93.01, and we end up with x squared equals 100.477. Square root this value, and you get x equals 10.02 approximately. So what we're saying is in this first triangle, they are approximately 10.0 meters apart. You would like to think we are done, but we're not. We have to repeat that exact same process with the other triangle. With the 5.9, the 7.8, 36, and we have to find that value of x. So we'll run through this process fairly quickly again. We are looking for 5.9 over sine of 36 equals 7.8 over sine of theta. This time, we are going to get, for theta, we get, if you notice, it's the same ratio. So when we solve through this, we are going to end up with our theta equals 50.99. And you're going to go, well, how's that possible? It's a different triangle. Remember, we're dealing with the law of sines, and therefore we have to look. This is an obtuse angle we are looking for. So we now need to go 180 subtract 50.99. And we get 129.01. So what we are going to use is 129.01, and we are now continuing from this point to find the other angle, the third angle. We go 180, subtract 129.01, subtract 36. We get 14.99. So that is the third angle. That is the angle we are going to use in our law of cosines. So we are going to have x squared equals 5.9 squared plus 7.8 squared minus 2 times 5.9 times 7.8 times cos of 14.99. And we can do that calculation now. Everything on the right-hand side, you're just using order of operations. Square each part, do your multiplication together, then add and subtract it, and we will end up with x squared equals 6.7433 approximately. Square root both sides, and approximately we get 2.59. So approximately 2.6 meters apart. So depending upon where they are standing, they may be 2.6 meters apart, or they may be 10 meters apart.